Hi, and welcome to this talk on remediation, particularly the automated kind, and the battle that everyone faces to get as close to zero vulnerabilities as possible. My name is Dan McKean, and I'm one of the product managers at Snyk. I work with two of our product teams that focus on the success of our users, including how well they do using the tools we offer to fix vulnerabilities. We've invested heavily in trying to make active and automated remediation as comprehensive and easy as possible, and I'm going to share some of our learnings as well as some new capabilities we offer to help. I'm going to start by covering the user problem, though we're all pretty familiar with the challenge that vulnerabilities pose. Then I'll spend a little time reviewing what the more general requirements of a security solution are when you're trying to solve this problem. Then I'll look at the importance of prevention in keeping vulnerability counts low, including a look at some of the ways Snyk aids with prevention. Next, I'll move on to the centerpiece, the importance of being able to automate as much of the remediation as possible to help you get to zero vulnerabilities without spending all of your time to manage it. In particular, I'll cover a new feature that's literally just released and goes a long way towards this goal. Finally, I'll show you some of the ways, including some new ones, that Snyk helps lower the cost of security, helping to minimize the friction in your process. We're all very familiar with the problem at hand. It's not even unique among the talks here at SnykCon. Whether you're a company of thousands of developers or a handful, vulnerabilities pose a high risk and a growing problem. Some of Snyk's biggest customers have over 200,000 vulnerabilities across thousands of projects. Even the average number of vulnerabilities is impressive at almost 6,000 per customer. And take into account that this is with Snyk's capabilities. Imagine what the numbers are like for the companies out there who have no comparable tool. Consider how long it would take to even get close to being vulnerability-free if you had to do all of this work manually. For each and every vulnerability, reviewing, prioritizing, preparing a fix, and then finally applying the change. When each of those vulnerabilities is in a different line of code, in a different project, it would be a daunting task to do without the aid of a specialized tool. It's no wonder that based on a recent report that we co-sponsored, 54% of companies have no choice but to deploy vulnerable code to production. So, what can you do about it? I figured we'd begin by looking at some of the fundamental requirements of the sort of tool that's needed in order to address this huge risk. I could be flippant and just say the answer is automation, but that's kind of stating the obvious. And while I do believe that it's absolutely a requirement for a solution to be able to scale to a large business, I don't think it's where you need to start when you're choosing the right tool in the first place. After all, automating substandard functionality is not going to help. You need a tool that is effective and capable. Otherwise, no amount of automation is going to get you close to zero vulnerabilities. Never mind, help you to stay there. So, the first critical thing is actually being able to find them. There's no use having a tool that can't be trusted to find all of your vulnerabilities. It's like locking your front door and leaving the back wide open. Almost worse would be a tool that found a high number of false positives, as that's only going to waste your valuable time. But the tool cannot stop at just finding them. You need a tool that supplements that detection with the intelligence for you to do the right thing, or better yet, does some or all of that work for you on your behalf. Critical information, such as whether there's actually a known exploit or whether the vulnerability can be reached in the code, are crucial to judging which vulnerabilities pose a genuine and immediate risk and which are just handy to fix in case they become a problem in the future. Next, you need something that's usable. I don't know about you, but I am drawn to complex tools, for a while at least. But the reality is that once you're stuck on how to do something, the novelty quickly evaporates. So the less friction and thought required when using a tool, the better. This is especially true when you need others to use that same tool, but maybe, given the choice, they'd rather ignore it. Since security often interrupts the work that development teams would rather be doing, find something that's intuitive and fits with their existing process. The less time it costs them, the less likely they are to question its value or avoid the work it requires of them, the more likely they are to accept it. And the more that happens, the quicker, easier, and cheaper it will be to get to a more secure position. Finally, we're back to automation. Besides finding the vulnerabilities in the first place, remediation is the part of the process that's most fitting for automation. It's also where we focus some of our recent work on a new feature that I've already mentioned and I'll be getting to shortly. As we've already considered, the time needed to review vulnerabilities, digest all of the sometimes conflicting information, decide what to fix, identify where and how, and finally actually prepare the change would cost a fortune if always done manually. As a result, we think it's only reasonable to expect a security tool to be able to minimize this with as much intelligent automation as possible, freeing up time and energy that everybody can use to better effect. So, to recap the key requirements, the tool be as accurate and thorough as possible to avoid leaving any unseen holes in your security or wasting your time with false positives. That it be simple and efficient enough that no one can object to using it, even when it's interrupting their preferred work. And lastly, that as much as possible be automated to minimize the overhead that it places on everyone's valuable time. Now that we've covered how, let's look at some of the things that the tool needs to be able to do. Before we dive headfirst into Snyk's automated remediation, which is, after all, the focus of this talk, I want to touch briefly on another important aspect of vulnerability management, prevention, but also why, for this problem, prevention isn't enough to get to zero vulnerabilities. It is, however, still critical. It can't entirely stop things getting worse. Not everything that's found can be fixed immediately, or even avoided, no matter how early it is found. But it is going to slow down how quickly new vulnerabilities build up in your backlog. And for the average Snyk customer, that's at a rate of about 100 new vulnerable code paths per day. If you can catch vulnerabilities before they even make it into production, you'll be in a far better position to strive for zero vulnerabilities. To aid prevention, Snyk offers various IDE integrations to help detect the use of vulnerable dependencies during coding. This minimizes future effort and saves development time. Our native Git integrations scan all new pull requests in a monitored repository for new vulnerabilities, meaning your changes will always be scanned before they're merged. Lastly, CI/CD integrations help catch and prevent any new vulnerabilities that have made it this far by adding Snyk testing to your pipelines. And while that's all great, as I said, on its own, it is not enough. Snyk finds, on average, 21 vulnerabilities in every newly monitored project. That means that on day one of using Snyk, if you had the average of 900 projects, that's about 18,000 vulnerabilities in a backlog that prevention is already too late to help. Something more active needs to be done. Snyk tackles automated remediation in three main ways. Each complements the other, but could also be used on its own, depending on your needs. And each brings you closer on the journey towards zero vulnerabilities. First, no matter how rigorously you avoid introducing new vulnerabilities, some will be found in code that's already deployed to production. Snyk has long had the ability to raise fixed pull requests to tackle these new vulnerabilities. So when new vulnerabilities are found during a recurring test, we raise a pull request to fix them, either with a Snyk patch or more commonly with dependency upgrades. Very little manual work is required. There's no need to watch for a notification, log in, raise a pull request. The fix will just appear in the SCM, ready and waiting for review, without security or developers doing any of the costly triage or prep work to fix every new vulnerability found. But wait, what about those vulnerabilities that already existed within the project and have for a while, especially the ones that existed when the project was first scanned by Snyk? With that, I'm very excited to announce a new feature, released literally only in the last few days. Snyk now offers automated backlog clearing pull requests. While the pull requests I just covered target new vulnerabilities, backlog clearing pull requests aim to whittle down the existing vulnerabilities on a project. So, on a daily or weekly basis, projects can get automated pull requests to fix the most critical vulnerabilities at a manageable pace. In this way, you can gradually reduce the security risk in the right order without overloading developers with more than they have time for. As with other Snyk pull requests, there's no need for a developer to do anything more than review them in the SCM. This saves time preparing a fix, but also working out which are the most pressing vulnerabilities to start with. Some of you may have attended my colleague Anna's talk on prioritization earlier today. In order to identify what to fix first when opening pull requests to clear the backlog, we're utilizing the new Snyk priority score, which uses a range of factors to determine the highest value vulnerability to start with. Not only does this account for the risk posed in theory by a vulnerability, but also the risk that vulnerability actually poses in the context of your environment. You may recognize these from Anna's talk, showing how the priority score takes into account important factors like exploit maturity, so whether there is a known exploit for the vulnerability in the wild, and reachability, whether the vulnerability is in a code path that's actually called within your code. You can even have the score take into account information you provide to Snyk about the project. Using our security policies, you can even change the severity of vulnerabilities based on criteria that you specify. A great example of this is reducing the severity for DDoS vulnerabilities when a project is only accessible internally. What this all boils down to is that project PRs work in a truly prioritized fashion, not only using information from our own assessment of the risk, but also taking into account the information and policies that you have set in Snyk to allow full context-aware prioritization. This means that when you start using Snyk, you'll automatically start on your journey to zero vulnerabilities with automatic PRs tackling the very worst of your vulnerabilities. Thirdly, and after that, possibly a little anticlimactically, automatic dependency upgrades. While maybe not as exciting as the idea of moving towards being totally secure, staying up to date is critical to reducing the cost of fixing vulnerabilities in the future. Some companies take the approach of always staying up to date with their dependencies. That's great, but for others, that's not always practical. The cost of so many updates, not to mention the effort sometimes required by major version changes, can impose a huge cost on staying current, and it's not always essential. So for many, this is an aspirational state. Perhaps something for the backlog of vulnerabilities is down to a manageable level. It can help in a few key ways. Fixing vulnerabilities always takes work and comes with some degree of risk. But by keeping dependencies up to date, the cost and the risk are reduced as the distance to move to a newer and more secure version is equally reduced. This can greatly shorten the time it takes to fix a new vulnerability, ensuring that you're protected sooner. Not only that, but staying up to date also helps avoid vulnerabilities that may be found on older versions. And as a final bonus, you may even fix a lingering vulnerability as part of an upgrade. Regardless of the higher level of automation, there's obviously still a cost to reviewing recommendations Snyk makes to help you be more secure. And we do what we can to minimize that. So not only do we offer configuration to help tailor it to your needs, we start with an approach designed to make this part of the process easier and more manageable. In terms of how each of these pull requests work, they're all part of the job performed when Snyk does a recurring test, which can be scheduled to weekly or daily. Since the last thing we want to do is overload an already busy development team, the backlog clearing pull requests are currently limited to 1 per project per day. We also prioritize our fixed pull requests that target fixing vulnerabilities over the ones that help you just stay up to date. So before an upgrade PR is raised, we count all Snyk pull requests in the repo, including prior fix and upgrade PRs, to ensure we stop at a configured limit. Vulnerability fixing pull requests will still be raised, but when the configured limit is hit, no more PRs with a focus on dependency upgrades will be raised, giving your teams the time to take a breath and catch up. Then, data shows us that PRs with less changes have a higher chance of being successfully merged. So for backlog pull requests, we fix only 1 vulnerability per pull request. And for dependency upgrades, we limit the number of packages bumped to 1 per PR. I've already mentioned that major version upgrades can have a high cost, both in complexity and time. And so for the pull requests that focus on keeping dependencies up to date, we also offer the choice to include or exclude major versions. And finally, with Snyk, the last thing we want to do is make things any worse. So we do our best to avoid recommending a version that introduces a new vulnerability. As I've said, a tool that introduces a lot of friction is at best going to give those people introducing it a poor reputation. And at worst, it's going to cost the business time and money, if it's even used at all. Which is why we take so much pride in tailoring our approach to our users and making sure that we do everything we can to try and help them achieve their own goals. In this case, 0 vulnerabilities. We know that even teams within the same company can have a very different style and approach, and there's rarely one process that suits everyone. So, as of recently, all of Snyk's automated pull requests can be enabled and configured either for all projects monitored via an integration or overridden on a per project basis. This can be done via either the API or the UI, and it can be extended beyond just accommodating different teams. You can tailor the level of attention you give different projects to suit their different needs and different levels of business importance. Despite the fact that these APIs and these settings are less than a month old, we actually have a customer who's already done this using a combination of the Snyk API and our new project attributes, which can be set in Snyk and can be used to record things like a project's business criticality. Next, we wanted to give all of our PRs the best chance possible of being seen and actioned. Looking at data we had available, we realized that assignees have a huge impact on merge rates. In 2019, the merge rate differed by over 25% in public GitHub repositories. So we've added the ability to automatically assign the PRs that Snyk raises. You can either have it assigned to the last user to make a commit, or override it with 1 or more specific usernames. This helps ensure that the right person sees the PR and drastically improves the likelihood that you realize the value of the recommendations that Snyk makes. Finally, we know that no matter how well automated the creation of a pull request is, the final stumbling block is the review. Knowing it will fix a vulnerability is one thing, knowing whether it will break something else is another. With that in mind, we've done a couple of things to make it that much easier to assess the risk. First, we've added release notes and commit history where we're able to pull it into the pull request. But that's still relying on you to make the judgment, and we thought we'd try and save you some of that effort. So next, we added merge advice. We have access to a fair bit of data on pull requests, so we figured we'd try and provide you with an automated assessment of the risk. Digging into many sources, Snyk analyzes other pull requests that previously made the same change as the pull request in question, looking at the merge rate, the test results, and whether the changes got rolled back. From this, we're able to give advice backed by real-world data to help expedite changes where we know it to be safe, or as safe as any change can ever be. So, to conclude, if only 3 things stick with you from this, remember that Snyk can help automate the journey to zero vulnerabilities in 3 crucial ways. Security is easier when dependencies are more up to date. Not only does it reduce the risk of new vulnerabilities being found, it's much easier to move to a new version to fix something if you're not too far behind. The last thing you want to do is make your security situation any worse. Not only does Snyk offer many methods of prevention, but we also offer automated fix PRs to resolve any newly found vulnerabilities. And last but not least, don't stop with prevention. Whittle down the backlog with Snyk's new backlog clearing pull requests to get rid of those vulnerabilities that have existed for a while and pose just as much risk as something brand new. Thank you for listening, and stay secure.